Good afternoon, everyone. Welcome to our panel discussion today on securing against emerging tech. During the next 30 minutes or so, this Q&A panel discussion will take a look at the various types of emerging technology that's come out, such as the Internet of Things, biometrics, technology in smart homes, smart cities, artificial intelligence and more, and what steps can be made and taken to secure against cyber attacks. So I'd like to, one by one, introduce our panellists to you, starting with Tim here.
Hi there. My name's Tim Moran. I'm the founder and CEO of a company called Nujab Cyber. And we were founded to deal with the problem of security of small networks, specifically the SME market, but also now with the growth of the Internet of Things, that's become even more of a challenge. So we focus very much on that area of the market.
Hello, I'm Adri. I work for BNP Paribas Group as Head of Technology Risk and Cyber Risk Analytics. I support the group and the BNP Paribas entities on using analytics for cyber risk, digital risk, fraud risk, and technology risk.
Hello, my name is Nicholas Palagias. I'm the CEO and founder of Padovo. We help businesses secure their organizations and protect their customers' identities. We have developed basically an AI platform that continuously authenticates the users, does not require any user input, by learning their behavioral patterns. So we're mainly focused on mobile devices at this point. We basically deploy a small library in a target mobile app, and then we do the data collection, offloading to the cloud, and then we do the inference about the behavior and the biometrics of the user. We're currently working with various stakeholders in healthcare, in the gambling sector. We're speaking with the MOD. We have a project now running with Samsung. So, yeah.
Thank you. We'll take any questions at the end, and I'd like to kick off by asking the panel, what do you consider to be the main types of emerging technologies that are most susceptible to cyber attacks today?
Well, actually, I think the real challenge with today is that anything that's machine-to-machine computing, connectivity, tends to be stuff that's not being monitored. In many instances, there's a race to the bottom where IoT equipment's being built out, and as a result, I think what we tend to find is that security is almost the last thing that's thought about in terms of trying to get the new wave of devices out. So I think the biggest challenge is all of that emerging tech, but specifically the machine-to-machine stuff.
We are observing in the group that companies are increasingly using machine learning-based security systems, and in doing so, we are sometimes forgetting the implications that machine learning-based security systems might have from an adversarial AI point of view. So, for example, of late we've been using a very known AI cybersecurity company, and we assume that their system is working very fine. However, once we started the audit process from adversarial AI perspective, we realized that we are sometimes not stopping the bad actors because the bad actors are subverting the system. So that's a key area of my research. My team's work is to see whether we can have audit methodology to find AI systems that are not working properly.
Yeah, I fully agree with Tim and Adri. So IoT is a great example of emerging technology where security has been neglected, I would say. Yeah, we definitely need to apply more harder regulations and standards in the IoT sector and in smart cities, for example, in order to secure basically the privacy of the users. machine learning and AI is also something that is currently very popular, and companies are trying to leverage this type of technologies. But the security element of the technology itself, so of AI and machine learning models, this is something that needs to be researched and more in-depth organized.
Thank you. Our next question is, how can modern AI systems be subverted to improve cyber attacks?
Yeah, so the key thing to understand is what type of adversarial attacks that might take place. So the premise of adversarial attacks is manipulating the models that have been developed based on a training data set. Now, we can never model the entire population. So what we are always trying to do is trying to create a function that models or classifies bad events to good events based on the data we fed the system. In some situations, what we can do is we can train the same system on adversarial data sets such that if a bad actor is using such approaches, we can preempt and understand that this is an adversarial attack and stop those bad actors from getting inside our system. So the focus is on having a wide panoply of training data set that considers adversarial instances.
Yeah, so I will talk a bit about our product in this case. So how we try to handle something like that is that we try, because individual biometrics and behavioral patterns have their own sources of error. So and they are susceptible to this type of attacks. So in order to be able to compensate and to be able to defend on such attacks, we try to engage a larger number of parameters that minimizes the risk. And so, for example, if someone uses a face recognition element and you do an evasion attack and modify somehow the input for the face recognition, you will have other types of parameters that will get engaged and will be able to understand that this is not the legitimate user and this is an imposter, to be able to cope with this type of attack.
I think when we get into this high level of technology and security, one of the big things that we tend to always forget is that a very, very large proportion of all of our sort of cyber attacks are delivered by the humans and human mind. And I think the training sets are just as easily subverted and can lead to false positives, that we sort of just keep going back through the cycle of events time and time again, where the reality is that false positives, human error, can more often than not be some of the bigger challenges that we have to deal with.
And our next question to the panel is, how can behavioural analytics be used to identify patterns and changes in behaviour and mitigate against cyber attacks in emerging technologies?
Yeah, so it's basically the whole process of understanding the behavioral patterns leads also to the understanding of potential anomalies. So these anomalies can constitute one factor that will let us understand that this is a potential threat and that certain defense mechanisms need to get engaged in order to cope with that type of attack. So by learning the different behavioral patterns, you are able to understand the sequence and the routines of the different systems, the different people, to be able to cope with such an attack.
This chair is really wobbly. Just one instance I will pick up is streaming anomaly detection, where data is coming like time series and quite event-based. Now, since we are doing real-time prediction, and just imagine a web intrusion detection system or application firewall that is defined to stop any attacks that is 20 times a minute, and 10 times a minute is fine. In a situation where adversary is just attacking, pinging 11 times a minute, it wouldn't be stopped as an adversarial situation. And in such cases, we are not updating the model, and sometimes we are updating the model in a wrong way, in which the adversary is slowly but steadily pinging to understand what's the underlying model that stops him from intrusion. So there is an idea which is not to let the model parameters be evident to the adversary. So in analytics, what you can do is you can transform the data set in such a way that from the core data to the transformed data, the adversary is not able to predict what has happened. So that's an approach to probably defend ourselves.
I'm sort of so pleased I'm out of the big enterprise space these days, because life's so much easier down in the SME world putting these things together. There's sort of two areas that we focus on actually, and the machine-to-machine stuff's pretty easy because we can map and understand the behaviour of all machine-to-machine traffic. So there's only two real reasons why that would ever change. Either there's been some form of software upgrade, or there's devices that have been infiltrated with some form of malware. So we, in our world, just go and quarantine devices as soon as we see that behaviour change on a machine-to-machine basis. At the sort of human level, we very easily track, using the likes of AWS as platforms today, the behaviour of people, users, from 1 hour to the next, compare them with the day before, the week before, the month before, 3 months before, and a year before. And it is amazing how easy it is to detect when someone's about to leave a company on the basis of that alone.
Thank you. The next question we have is how can defence be increased against evasion attacks?
Quite frankly, this is not my massive area of expertise, but I think it's really back to all the data sets and how big you can build the data sets and how accurate those data sets can be. And as long as you have a level of physical security around those data sets so that no one can infiltrate that particular sort of element of it, then I think that you're in relatively good shape.
So temporal bias of the data, which is tail data. The other thing is model explanation. So if we have models that are classifying bad events, good events, and if the analyst is not able to gauge how the model comes to the decision criteria, then it's very difficult to defend. So model explanation or explainable AI is a very important thing. And I was just reading that DARPA is working on these areas, which is adversarial AI plus explainable AI, so that in cyber world, a model can be defined and explained that is making those predictions. So that's one approach.
I believe that a key element in avoiding such attacks is, of course, the data that are used in order to train such models. But in real case situation, you have a lot of noise and a lot of other factors that affect basically the data that are put in the model. So I think a key element is filtering. So you do use AI and machine learning in order to filter the data, clean them out, remove any garbage or any information that could affect your model in a way that we don't want, and then to allow the whole processing to take through.
And our next question is, what defensive approaches can the security and machine learning community pursue? And are there any emerging security technologies that focus primarily on security in these two areas?
I've been seeing that a lot of companies are using data science for malware detection. And again, we are going to come to the adversarial realm. Those data science systems that are being developed to find not malware-based signatures, but on analytics, are susceptible to get misclassified. So a good approach is to not only use IOCs, but to use TTPs from dark deep web, where you can understand which are the trending approaches, techniques, tactics that adversaries are taking, and to have a continuous analytics engine that can cross-contextualize those situations and update the model. So use human-generated adversarial data to update the decision models.
Yeah, so we could use different types of technologies, in my opinion, in order to cope with such challenges such as blockchain, AI, machine learning, that allow to create certain levels of defense and to be able to cope with different types of attack, like distributed denial of service, or other types of evasion attacks.
So again, I'm going to sort of bring this back to a rather more sort of simplistic level. We always talk about multiple layers of defence, and those, I think, also play out in the same environment. I think education is something that is continually missed and must be a massive focus, but specifically when we're dealing with machine-to-machine learning, I think there's an awful lot of information that people can learn from the DNS data, and we as a company spend probably 50% of our time analysing every single connection from every machine to every machine to every service in the cloud.
Thank you, Tim. Next question for the panel is, how important is securing simple Internet of Things devices, especially those that have weak security? For example, some products will have a low price point, but will also have low security as a result. So how can these be properly secured against cyber attacks?
So I think it's relatively easy to deal with this side of things. I mean, again, going back to the sort of DNS data and on the machine-to-machine side of stuff, we're all familiar with. I'm sure we're all familiar, at least, with the likes of Shodan and how easy it is to recruit IoT devices into botnets. I mean, the harsh reality is that they are very predictable, and as I said before, you either quarantine a device because it's behaving badly or because its behavior has changed, and it might be good, but you quarantine it in any event. I cannot personally see that the issue of security in IoT devices is going to be solved anytime soon. There's just a massive race to the bottom in terms of price, and people just want to get their products out there as fast as possible. So you've got to take this layered approach, look at the DNS data, look at the predictability of the traffic, and quarantine if it goes out of spec.
Internet of Things is a great emerging technology, but we need. I understand that because of, as Tim mentioned, that in order to increase the scale and the growth of the area, we have to lower the prices and the cost of production of these IoT devices. But this comes always at the trade-off of security. And we need to increase the types of standards in terms of security that are added to these devices. We could use different types of elements to do predictive analysis of the actual devices and potential vulnerabilities. We need to have solutions that continuously monitor and prevent any vulnerabilities. And also the third element is education, which is quite neglected. So people need to be educated about the consequences of a potential IoT attack and what this can lead. Because we're adding IoT devices in our homes, such as Alexa, such as a smart alarm, a smart fridge, but all these we can add a microphone to monitor a baby. But all these things can be exploited, and the past have already showed this type of situations, and we need to be aware of what are the consequences of adding such a device and how can we prevent such attacks in our homes and in the larger IoT area.
And it's also probably important for us to question the vendors, what security posture they have, what methodologies they are following. And another key thing that I observed while talking to a vendor, instead of defending the perimeter or looking outside the perimeter, what they're doing is they're monitoring the actors. They're trying to classify actors based on intention to attack. So a nation state or organized criminal organizations they have an intention to attack, they're mobilizing to attack, and they're actively running campaigns. So instead of firewall in the perimeter, they are putting a firewall which is closer to the attackers. So I think that could be a good approach to see botnets.
Thank you. And the final question for our panelists this afternoon, how can security be improved with autonomous devices, especially with self-driving cars as an example?
I'll again use the word adversarial AI. I mean, if you've seen some research from academia industry, like it's quite easy to manipulate pixels and to falsify the prediction that the self-driving car engine, self-driving car system is making by just very easy manipulation. I don't know the answer, but I've been following research. People are working hard towards it because that's one of the key criteria for us to believe that the self-driving car will become a mass market technology. And it's not easy to attack such systems.
So I think there's a couple of things actually. Obviously, you would hope that everyone's encrypting all of that traffic back and forth over the wide area. I'm not so sure that I've seen that happen in practice everywhere to date. Again, monitoring the behaviour of the traffic. You know, if you've got a particular manufacturer's car calling home with all its diagnostics data, again, that traffic should be relatively predictable. So that is also a really important area to monitor. And I think that those for me are probably the two of the big things. The third and final one, I think, is really looking at behavioural systems that sit within the server-side environment within those autonomous vehicles. You have to start monitoring those the same way that we've been monitoring with antivirus on desktops and the like for many years. But these are different types of systems that are monitoring the core behaviour of the control systems.
Autonomous cars create a large amount of data and through the different sensors, because in order to be able to achieve the autonomy that we were envisioning, you need to collect a vast, a large amount of data. So these data, we need to understand to whom they belong, how we protect them, and what type of security measures we need to enforce to the different cars in order to protect the privacy and the security of and the safety of the passengers. Yeah.
Thank you very much to all our panelists this afternoon. I'd like to take any questions from the audience, if you have any.
So, so a lot of the conversation was about AI, machine learning, the growth of security taking care of itself to some extent. However, as with IoT, that creates a whole new threat problem where the machine now begins to change, particularly in the cloud environment, begins to change your own infrastructure in order to mitigate a given threat or what it perceives as a threat. And at some point in time, because humans are humans, we're going to give a good portion of that control over to the AI to manage. how are we going to manage the change in infrastructure so that we are assuring, as adversaries continue to advance, that they are not manipulating the AI's behavioral systems to get around it or infect their systems anyway?
Well, I think that's probably the million-dollar question, right? And how's it going to be dealt with? I think it goes back to the training, the data sets, looking at all that side of stuff again, looking at and making sure that you minimise the ability for those data sets to be played with in whatever way, shape, or form that might look. But I think it's a massive challenge. I mean, I think the other side of this is, of course, that really you have to understand which are the attacks that you're trying to stop. Because we spend, as technologists in the cyber industry, a massive amount of time talking about the latest and greatest stuff, when in reality, if you take my particular sector, which is the SMEs, 95% of all attacks could be stopped by implementing the 5 controls that sit behind Cyber Essentials. So we can. I think it's a big problem, but it's not a big problem that I think we've started to really worry about just yet.
Hi there. Some of the things that Ati was talking about the modelling side of it and the parameters and trying to hide it, gave me a sort of an idea that it's very nascent, just get bounced off you really, which is that we talk a lot about artificial intelligence, and we talk about the defensive technologies and the responsive technologies, and we talk about how malicious parties can use AI to attack us, and it all becomes a war, arms race, blah blah. But at another bit, if we're making computer technology more like us, i.e. building artificial intelligence, and we also quite often recognise that humans are the weakest link in a lot we do in cyber security, then is there not scope for actually making them more intelligent and think for themselves, actually make us susceptible to attack, and possibly even being able to be led by a malicious party by feeding them information that makes their neurons work in a way that they accept a certain behaviour as being normal when in fact it isn't? It's a bit of a sort of out there on the edge, but what are your thoughts on that really?
So I think it could be talked in a way of war gaming. So there is this idea of purple teaming, and autonomous purple teaming, which means can you generate artifacts, forensic artifacts, which are autonomous, and then can you send them to machines and man to see how their defensive posture is improved through those artifacts that are generated. Now, personally, my institution, I don't know how conducive will be to such experiment, but I think for small institutions, it's probably a less bureaucratic approach, and I mean, wargaming is just situational awareness.
Okay, I'm afraid that's all we've got time for on this panel discussion on securing emerging technologies. My name's Lisa Ventura, I'm from the UK Cybersecurity Association. Thank you all for joining us this afternoon. Have a good day. Thank you.
Thank you.
Thank you.